What is up, people? I hope you're doing great. As promised, these are my favorite equations to solve. I know we got some weird words up here, right? 2-7 is all about these things called literal equations. And then we got this other junk down here we don't really care about. Dimensional analysis. Your science teacher, now or in the future, would probably like you to know this stuff. Basically, it's the process of carrying all these different units, you like unit rates out throughout a problem, so that you can convert, milligrams into uh, kilograms, or pounds or ounces or whatever. Like, here's the deal: we're just gonna do the good stuff, right? This one right here, literal equations. Okay, guys, what is a literal equation? This is an equation that is made up of literally letters. An equation made up of letters and numbers. Okay? There's going to be some numbers in there. So really, letters, probably a better word would be variables. We might be more familiar with that one. But we're going to see just variables in these. And we're just going to kind of like rearrange them to solve for a specific variable. That doesn't sound so hard. Freaky, come on, man. Well, here's the deal, guys. It's not any different than what we're doing. The problem is, and you'll see, when we go to simplify these, unlike, when we move like 16 over to the right-hand side, we subtract it, we add it, right? And then we would get a new number. Well, that doesn't happen, right? We're just subtracting something, and it just stays there. So we're going to spend a couple days on literal equations, all right, just so that we can understand them. We will get better and better and better, I promise, at them as we move forward. Okay, so here we go. So here's our first one, all right, and this is what we're talking about, right? So we've got numbers and letters. So we've got, like variable terms, constant term, and it says, right, solve this equation for B. So this is where we have to use good equation like skills, right? Hopefully we have a good foundation that we've laid with solving equations, and we know what to do, right? So isolate the variable. So leave this alone. Leave it here. Move everybody else to the other side. Okay, so we're adding 12c, so I want to subtract 12c, right? And here's why stuff gets weird. Again, this cancels out. I'm left with 5b. But now, this doesn't combine to a number. We get an expression here, and that's fine. That's okay, all right? Leave this, guys. Be careful how you write this stuff, okay? So 9 minus 12c, right? That's just what it turns into. I don't know what it is, okay? Pretend this was 9. What would we do next? You're right. We would divide by 5. That's what I want you to do, okay? So we're going to divide by 5. Divide by 5. Okay? Well, how do I divide an expression by 5? Well, we can show this two ways, right? The first way is, if we think about this, each term, right, in this expression, 9 and this negative 12c, both of them are being divided by 5. So if we would like to write it, guys, as, hey, 9 divided by 5, or 9/5, minus 12c divided by 5, this is perfectly fine, okay? If we were to get a nice number here, like, oh, man, wouldn't it be great if this was 10? Oh, wouldn't it be great if this was 20, right? Those would divide to good numbers. Then you could do something with it, right? But I suppose as it is here, we're just going to leave it like this, okay? So this is, I would say, a very nice way to write this. The other way to write it is literally right here, guys. Okay, that way works too. It's saying, hey, 9 minus 12c divided by 5, right? These are what we would call equivalent expressions, right? When I say these, I'm talking about my two rectangles here. These are equivalent to each other. And we're done. We've solved for B. We haven't really done anything, guys. We don't have a numeric answer for these. That's why they're kind of weird. This is one of those abstract concepts we deal with, okay? So we're just kind of shuffling and rearranging, right, these equations around so that we can solve them. Okay, let's see what else they can throw at us. Alrighty. Okay. Solve this one. Scooch this one up a bit. There we go. Tons of room now. Solve for y. Again, kind of looks like the same one. Again, be a good equation solver. Isolate your variable, leave it here. Let's move this 2x over here, right? Again, this is a positive 2x. So we're going to subtract 2x from both sides, right? Goes away here, right? I got this, 13 minus 2x. However, I've done something wrong already. Look back at this, right? What have I done wrong already? This is somewhat common, so we need to watch out for it. So pause this, look at it, figure it out. Raise your hand when you got it. Okay, we got a couple people over here. A couple there. Right, so come on, right side of class. Let's go. Oh, there you go. Okay. Yeah, you guys figured it out. I forgot all about this dude right here. Okay? It's a negative 17. It needs to stay that way. Okay? Now, we only have one step left to do, right? These aren't that bad. These are just two-steppers. Divide by that coefficient of negative 17. This is why that negative is kind of a big deal, right? Dividing by a positive number and a negative number aren't going to give us the same expression. So here we're dividing by negative 17. Over here we're going to divide by negative 17. Again, guys, I don't care which way you write it. 13 minus 2x all over negative 17. Okay, so let's do like a good, better, best. Do we really like to have negative signs in our denominator? No, not really, okay? I can easily get rid of that by basically saying, hey, you know what? If I multiply this guy by negative 1, it will make it go away. But then I've got to multiply everybody by negative 1, okay? So really, here's what happens. So again, multiply here by negative 1, multiply here, multiply this guy. Be careful, it's negative 2x, right? So this would turn into positive 2x, okay? So here's a good answer now, okay? As I just cut off part of it, right? So y equals negative 13 plus 2x over 17. When you check your answers on some of this stuff in the book, we might see this one, and you might have stopped here. Just know that, hey, you're close. We just got to get rid of this. Could we also write this with each one of those fractions broken out? Yes, we could. You could say negative 13/17 plus 2x over 17, okay? So that one works too, all right? Again, I don't care about this one or this one, right? But let's try to get away from just negative ones. Again, this is okay. I suppose technically it's still somewhat correct, but as you guys know, we don't like negatives in the denominator. And that's how we get rid of them, okay? Sweet. Oh, boy. Okay, here we go. Oh, we just amped up our game here big time. Okay, so underline everywhere you see the variable x in here. I got you. I see an x here, and I also see one over here. How am I going to solve for an equation if I've got two of them, but I see this one over here is tied to another variable? This is a head scratcher for sure. All right, here's what I want us to do, okay? Again, good equation foundations say get your variables on one side. I understand, guys, I got 7x, and then I've got this xy. I want to bring them together to one side, okay? So let's do that. Let's move xy over here, right? We're subtracting it in the expression on the right, so we're going to go ahead and add it, okay? Okay. Is xy going to add to either of these terms? No. This is why things look weird. So I have 7x minus 2z plus xy equals, now I'm just left with 4, okay? Again, I still don't know what I'm going to do with x, y, but I know I got to get rid of this 2z, and it's got to move over to the right with 4. So let's do that. We're subtracting it, so we're going to go ahead and add 2z. Again, hit 4 plus 2z. Does that turn into 6z? No, absolutely not. Right? Somebody just shouted it out. They said, no way. Okay? 4 plus 2. Make sure your z's look like z's, not the number 2's. Okay? All right, there we go. This is what we want to have happen, my friends. Okay? Look. I've got 2 x's here. I wonder if I could somehow magically pull an x out of each one of these terms. Well, good news there is a way to do that through one of my all-time favorite things that we do. It's called factoring. Okay? This is like the opposite of the distributive property. Okay? So what I want you guys to do here is think about, if I pull, again, think about what we want. I want this x right here. Bam. If I take an x away from both of these terms, right, and it's kind of like working backwards, what expression would go in here that when I would multiply, right, and use the distributive property, multiply x into these two terms, that it would look like this 7x plus xy? Think about that. What expression could go in here? In here, okay, to make, when I use distributive property, it would turn into this. Ah, yes, you got it. Somebody said it back there. They said, hey, 7 plus y. Absolutely, okay? Guys, this is a process we call factoring. It's kind of like dividing, like in a weird kind of way. Like I basically divided an x from this one, and it turned into 7. I divide the x out of this one, and it just turns into y. I know what you're asking. How does this help me? I'm still no closer to solving for x, but we are. Think about what we just did. What does the left-hand side tell me now? It says this term right here, this variable x multiplied by this, right? Guys, it's kind of like this. When we get, hey, 5x equals whatever you want over here, right? We've got two things, and they're being multiplied together. Well, if I want to get rid of one of the things, what have we been doing? We divide by that. Now, it's always been a number, so we've gotten, a number over here. I want to divide, right? I just have one step to go. Divide here. Should I divide by x? That's what I want to solve for. I want to divide by this weird expression, right, that we factored out. So I want to divide this side by 7 plus y. Whatever I do to one side, I've got to do to the other side. So we're going to divide this expression by 7 plus y, right? This is what x is equal to now, guys, right here. Okay? Bam. I was just lazy. I ran out of room. I didn't want to rewrite it. That's what we're after, okay? There is no breaking this apart, folks. When you make it this far, you pat yourself on the back because you did a great job. This is as hard as they can make these literal equations, okay? We just have to remember, like, hey, keep doing what we're supposed to do to solve equations. Isolate your variables, move the other stuff over there, okay? Bam. Okay, here's another one of these, guys. I immediately am drawn to the fact that I see an A and I see an AB, right? Here's my, here's A, and there's AB. It's kind of cool how I do that. So let's bring them together. Let's move 3C over here with 6, okay? To be different, I'll move 3C over here first. We're going to subtract 3C. So 12A, right, we're going to go minus 3C, okay, equals 2AB plus 6 minus 3C. Again, nothing combines. Don't combine any of this. If like terms, guys, same variable, same power. AB Not going to combine with 6. Nothing's going to combine with C. Okay. Now I want to move my AB over here. No, we're not talking about Antonio Brown. We're talking about 2AB. Right? We're going to subtract it. If you don't know who Antonio Brown is, just don't worry about it. It's a football reference for all my guys out there. Okay. Will these combine? I don't think so. 12A minus 2AB equals, that went away, we have this weird expression here. 6 minus 3C. Do you have to write the 6 first? No, but you have to keep the signs the same. You could also write this, guys, as negative 3C plus 6. That's fine. I don't really care about that order. All right, we got to do that same thing we call factoring again. So it's like the opposite of the distributive property. I want to factor out an A from each one of these expressions, from 12A and from 2AB. I want to factor out an A. Okay? Shaboink. 6 minus 3C. So what can I put in here to factor out an A? Ooh. Yeah, what do you got? 12? Okay, yeah, that's a good start. 12 minus, somebody said, yeah, 2B. Good work, people. There you are. Again, can you check this to make sure you factored it right? Absolutely. Take your A, distribute it back in here. You can just do mental math. You don't have to write it out. Does it turn into this? Yeah, that's how I know I haven't changed, this expression at all. I've just changed the way it looks, These are equivalent expressions here, okay? Now this is what we need to happen. We've got this A multiplied by this, 12 minus 2B. Multiplying two things together, break them up with division, okay? What do you want to divide by? Well, we always want to get our variable by itself. So we're not going to divide by our variable, we're going to divide by this. Whatever I've done to one side, I need to do to the other. 12 minus 2B, This equals A. Careful, sometimes A's look like 9s if you're not careful, Anyway. Okay, and we're good to go, Don't have to go any more than that. These are the hardest ones, I think, in the entire universe, guys. Okay? So don't get frustrated if you can't. All right, so here we go. So we got some word problems, of course. When you see the word problems, you know we're getting to the end of this stuff. All right? Let's make this a smidge larger. There we go. A car's fuel economy, E, miles per gallon, is given by this weird formula. E equals M over G. And they tell me what the M and the G are. M is the number of miles we drive, and G is the number of gallons we use. Okay? Here it says solve the formula for M. So I want to take this and solve it for M. I really wish they would have said solve for G, and I think we're going to do that here in a second. Okay, so let me move this up. I want to have a little bit more room. Okay, so E equals M over G. I'm going to solve it both ways, guys. The very first we'll answer their question. We'll solve for M. Okay? So how do I get this? Get this G out of here, So now we're dividing two things. How do I break up division? What's the opposite of dividing? Well, we're multiplying, When you ask me for help on these ones, I say, read this out loud to me. And you go, M over G. And then I say, over means what? And you go, well, M divided by G. So the opposite of dividing by G, guys, is to multiply by it. Whatever I do to this side, got to do to this side. Okay? Can I multiply two variables together? Yeah, don't leave your answer like this. No, just multiply these together. Hey, GE equals M, My two G's over here cancel out. Any number that you divide by G and then multiply by G is just going to be that number. So you can write it as this, This kind of refers to you guys. You guys like a gem, you know what I mean? So that's good. If you wanted to write EG, because you're like, hey, they got to be in alphabetical order, that's fine too. Okay? Either one of these are fine. Doesn't matter. Multiplying. Okay. Let's try this solving for G. This is a little bit trickier. And we are going to have some ones, guys, that look like this. M over G. Okay, so if this one were to say solve for G, look, it says that now, okay? Here's what, think about what needs to happen. Well, I need to get G all by itself on one side. So M divided by G. Oh, we're dividing by G. Well, can't I just multiply by M and multiply both sides by M? No, because when you do that, this doesn't go away. Oh, well then can I just divide by M? No, because that's not going to work either. Here's what has to happen. If I want to solve for G, it's kind of counterintuitive, but I need to move G over here with E first. Okay, so we kind of know what that looks like because we just did it. And then now that I have G and E held together with some operation, then I can maybe move E over to the right. So that's what we're going to do. So the very first step, guys, looks identical to what we just did. Right? We multiply by G. So now I get GE equals M. Okay? Stay with me. Right? Can I get rid of E now? Look, I want to solve for this. Yeah, we can. Right? We were just doing that a second ago. I've got two variables. They're being held together with multiplication. How can I break them up? With division. So I just want to divide here by E. Divide here by E. Okay? So G equals this M divided by E. Okay? That's what that would look like. So look, really what happened, guys, and this always happens, is these two really end up switching spots, right? It takes us 2 moves to get there because move 1 was multiply by G on both sides. Move 2 is to divide by E. But this always happens, right? When you get into geometry and algebra 2 and you start to solve trig ratios, right? You will do this all the time and it will just become second nature. All right, but until then, right, just go through these 2 steps here. Okay, and guys, I think that's really about it, right? Like I said, I'm not too concerned with all this dimensional analysis stuff that they got going on with here. I mean, if you really want to get into these, I mean, I suppose we can. Oh, wait, hold on. My bad. Other stuff going on here. Again, we could just use the formula that we made on this one. Sure. We can solve this. Of course, now I've lost my equation that I had. Darn the bad luck, guys. That's what we say. Hold on, let me bring it back here. We've got E equals M over G. Sorry. All right. E equals M over G. All right, so they said Q's car had an average fuel consumption of 30 miles per gallon, and she used 9.5 gallons. How far did she drive, right? So in other words, this is 30. We don't know how many miles she drove, and this is 9.5, okay? Well, look, this doesn't really do me any good because, sure, we could solve that, or we could just use the new equation that we came up with, all right, which was that one, right? Or I think we had it like that, gem, okay? So really, if we put these 2 numbers together, right, this was gallons we used, 9.5, right? This was the average fuel consumption, which was E, which relates to 30. Okay, and now we can solve this. So this is kind of why we do this, right? We use the equations that we rearrange just so that we can plug in some better numbers here. Sure, I'll try this one on my head for you guys. So that's going to be 270. That's going to be 15. 270 plus 15 is 285. If that isn't right, somebody yell at me. No, yell. Did I get it right? Okay, good. All right. So there we go. So there's that example. I got ahead of myself. I forgot we had this one in here because now they want us to solve for G, which we just did, right? Remember, we figured out that those 2 flip-flop places. And then here we go. Yeah. So again, another problem there. Yeah, here's all the dimensional analysis stuff that I don't really worry about, okay? So guys, that's literal equations. The best way to get better at literal equations is to do about 9,407 of them, okay? They're not fun. They will get better, right? Just have your good equation foundation stuff and say, hey, here's my variable, right? Let's move the other stuff to the other side, leave it here. Sometimes we have those factoring ones, right, where we have an AB and an A, and we got to factor something out, okay? Look back, right, at those examples to help jog your memory for what to do. So anyway, so with that, guys, dig into all the other fun stuff we got going on for literal equations. If you have questions, ask me. Other than that, be awesome.